Are you in need of any assistance today, sir?
No.
I could help you cross the street.
No.
I could help you cross your yard.
No.
If you really want to help me, what I need to do next is to write the report for this data set. I've got my plot and I know what I'm doing. Title's not too hard, but intro is. I think I'll leave that till last. So I'm going to start by talking about the errors in the data set. Of course, it's a data set about errors, so it's going to have errors. That was the joke. There were 6 different errors, but this one was just how R read in the data. It's not that the data itself was flawed. But here was where we had a large value on errors that we took out. We had a blank spot somewhere. We had negative values here that we turned positive. And then we had this mix-up with lowercase and capital case classical. So I'm going to make a note of those. Anytime you're taking the client's data and changing it, they deserve to be aware of that. Interestingly, because the video was paused and I was sitting here looking at it, I noticed I'm using the words we instead of I or the researcher. That's a style choice. It doesn't matter. You really ought to try to be consistent. Now that I've started with we, I'm going to have to try to make sure that that's the language I'm using the whole time. But it doesn't matter in this class which style you're using. Next, I'm going to use the picture. I could have started with the prediction equation. It's not like there's a particular order, and you certainly shouldn't feel like you have to go in whatever order the rubric says. It's not enough to just have a picture. I also need a couple sentences of what are we seeing here. Rock music is the best for low errors, but it takes a lot of time if you have a lot of errors. And these guys here seem to have slopes that are pretty similar. Even though they may seem similar, looking at the summary fit, they're all different except control is different from alternative. This large p-value does not mean the control has no slope. It doesn't mean that the control slope is flat or 0. It means control is the same as the baseline, which is alternative. So the black and blue lines here are pretty similar. And looking at the picture, yeah, that makes sense. So in my report, I'm going to state those p-values were significant, but when I talk about control group, I'm not going to say there's no slope. I'm going to say it has the same slope as alternative, which was our baseline. Next, I've decided to put my prediction equation in there, and I've got a couple different options. One is to take those 4 different equations. Let's make them look nice. I'm going to separate them into the 4 different types, and also going to get rid of the hats because that's our code. And then I want to simplify it so that instead of having multiple slopes and intercepts for each of them, they're all different like this. Beautiful. This is one way to do it. You've separated these into the 4 different pieces. A different way to do it is to take that big prediction equation with all of them together, make it look nice, get rid of the hats, and then make a note. How do you handle this categorical variable? Well, it's either 1 or 0 based off whether that's the category or not. And we want to do that for the other groups. And I even made a note for how to handle the baseline just because I think it's helpful to the client and to you perhaps. I want to talk about S and R squared. I need me a conclusion that really summarizes the important parts. What's important? Rock music is good if there's few errors. Classical music is better if there's lots of errors. Now that I'm basically done, I'm going to come back up here and try to do some sort of introduction here. I'm going to make it sound important, like what we're doing could really help a student who's frustrated. I decided to throw something in here just because I want to emphasize it. Some people might say you should split the data into pieces. You could have the rock data and you could run regression on that. And then you could have the classical data and run regression on that, all separately. But I didn't want to split into 4 pieces because if I put all the data together, then all the data can work together to analyze the error and the variances. This gives us better, more accurate results. And in this case, all the data is supposed to have the same error structure, so putting it all into one model gives us a more powerful analysis. In fact, some people call this an analysis of variance, which is ANOVA. That's a term that gets thrown around a lot and implies a whole lot of things. What we're doing with categorical effects here is ANOVA, and we're doing ANOVA from the regression viewpoint. But if you hear those terms thrown around, this is what it means. That we have multiple variables, categorical and numerical, all trying to predict our numerical value, in this case, the time to do a data set.